All right. Okay. So we have been discussing in yesterday's session, that what are some of the ways we should be actually building our AI on our local systems, and then uh, we can train it on the cloud or anywhere. And then basically, how do we need to do all of the integration stuff and everything? And then basically, how can we, you know, maybe deploy it via I mean, full deployment we haven't talked about, but yes, I mean, a simple classification model, let's say if you want to host it, definitely we have seen it. Then basically we can either convert it into an API or something like that. However, today we'll see some more complex methods and production grade things. Basically, what are the best practices, or what are all of these startups doing, behind the scene? What are they actually hosting and all of those things? So I'll just switch to this. Hold on a second. Okay, all right. So basically, how it goes is, that till now we have seen that what should be the question. However, ultimately the question is that what should be the best production grade uh, hosting, best production grade hosting, right? Now, obviously, there are various tools available nowadays, but however, since it is all about LLM now, hence we are talking about LLM, but it is not going to be the case that always in future it is going to be the LLMs, right? There are multiple types of models that are present. Most of them we have discussed, but it is not that this doesn't end the universe here, right? The universe is much bigger, and there is something called as, Bayesian neural networks that work on probability, and there might be a chance that these neural networks just shine away. It is just about, who has done the right experimentation and all of those things. Now, because even when I'm thinking to roll down a paper, there is a lot of experimentation involved, when I have to provide the proofs and everything. So obviously, for the bigger the model is, the more amount of money and everything is you need to spend and everything, right? So best production grid hosting that we can give, obviously, if it is a non-generative model, if it is a non-generative model, you can always choose basically uh, what you want to host. Let's say you can provide a simple hosting. You can just do a simple hosting in the sense as it is model, right? You can just do that as it is. Or second, what you can also choose is you can convert it into various other formats. You can convert it into C formats. There are various libraries that can help you in doing that. C and C++, right? There are various libraries that can help you in doing that. Even non-generative model also you can do that. C and C++ format. It is just, I mean, they're not very much widely supported. You can convert them into Onyx format, right? Onyx is again open neural network format, Onyx format, and then there are various libraries you can use for better hosting them, you know, better hosting. All of these things you can do. So you can host your models in any of these manner, and then obviously model hosting, efficient model hosting, mostly it goes around C and C++ only. That because these are the fastest libraries that we have known ever in the computing history. However, when it comes to generative AI, since nowadays it is all about generative AI, but like I said, it is not that in future it is just going to be the case. So generative AI, obviously, we have seen various ways. One, today, what I'll be just showing you, simple hosting. That is, I can simply load it using Transformers library. I can load it using Transformers library, and then I can maybe just provide the inference endpoint API and all of those things I can do. Right. This is, I mean, if I'm doing it for some demo project or something, this is a fine way of doing it. However, then again, I will have to convert it using C++ or something, right? So in C++, we have like Llama CPP, we have Llama CPP, we have CTranslate. These are some of the now. actually CTranslate, and then now we have CTransformer also. CTransformer, these are some of the libraries. Llama CPP being some one of the most oldest and very stable version, right? We can go ahead and use it. We have used it. A lot of other people use it. So basically, it reduces the memory consumption, and also the speed is also quite good. Speed is also quite good. Then obviously the third point is that okay, it is like okay, we are GPU rich, we are not GPU poor, and we have enough amount of GPUs, let's say, and the customer or the aim of our project is, I mean, lightning speed. Then obviously, and most of these lightning speeds, then they are on VLLM. Most of them are on VLLM, right? Uh, there are other Hugging Face also provides a inference library. Hugging Face also has their own inference library, which can be used again. It is again an efficient version of these transformers. It is again efficient version. So we have VLLM. VLLM is as of now the fastest one. Now the how it goes, that obviously what you can do is, what you can do is that obviously you can choose the VLLM, you can choose VLLM, and then what we will see today is we'll see two ways to host VLLM. One is vanilla VLLM, right? One is just like the vanilla VLLM, how we can do it. And along with vanilla VLLM, we'll see you can have VLLM server, VLLM server, and this same VLLM server you can actually embed in the Dockers also, can embed in the Docker. So the advantage, this is a production grade system, just VLLM server. It gives you with all the API endpoints, it gives you all the API endpoints of your large language model and everything, authentication and everything will be taken care of, right? All of the authentication and everything, it will be taken care of, right? So this is how it goes. So basically, like I said, we will be discussing other things, but yeah, I mean, the whole focus is going to be on this part. We'll see that how to use this VLLM server and see all of these API endpoints and everything, and then we can see all of these, right? All right. So with that discussion, I mean, let's go to the practical things. So basically, first and foremost thing, like I said, I have to demonstrate that, we have yesterday seen that how we can load the classification model into our memory, and then we can provide that inference. But now what we are trying to do, we will load the generative model. And obviously, this is nothing new that I'm showing you. It's just I'm showing you in the local machine, right? So I'll show you in the local machine that how do we need to do it, and then how do we need to provide the inference, right? So with that, I'll just share. Okay, let me. Visual Studio Code. Okay, all right. So yes, I mean, we'll again jump back to our Visual Studio Code, and in Visual Studio Code itself, I can just have my Jupyter notebook. You can just install all the required things here. I'll just save it here. Maybe local LLM or something. Although I already have one file because I had to test it. I mean that if everything is installed or not. Right. So now let me just start. All right, and just wait a minute. I'll just select the right kernel. What are the Jupyter notebook environments, Python environments I have to use? I can use AI Live, or basically I will have to use AI Live environment because obviously, and then like let me start importing, import torch, right? And then import all the transformers. Now again, this we have already seen n number of times. Actually, every time we have been loading, from import transformers, we have to we can import pipeline or any other ways we can import it, right? Just give me 1 minute. All right. So we can just use pipeline or anything else that we have been using already. This time just I am actually running it from local machine. That's it. Auto casual pipeline we have used last time. We can this time use auto model for casual LM, right? Auto model for casual LM, right? Auto tokenizer. The only problem here is that you have to take care of everything. In Colab, you get all the things from transformers. Okay, yes, okay. Cannot import auto model for casual LM. Auto model for casual LM. Auto model on casual LM. Right, we have it. All right, we have got it here. All right. Now, basically, what I will do is I will simply use a very small model, right? Model underscore name. So I'm going to use a tiny llama a model. So tiny llama is again, it is 1.1 billion model that I can use. So I'll just copy its name, maybe tiny llama, right? And you can just visit the website and it is present there, the tiny llama model. This is the tiny llama model, and then we just need to install it, right? We need to load our tokenizer and the models. So tokenizer first we can load just, okay, getting this, and then we can just have our tokenizers. So tokenizer model for casual LM. And it goes as auto tokenizer, okay, from pre-trained, and tokenizer also is from the model name, so I could just load the model underscore name. Like I said, you have seen this code a number of times, and this is basically I'm loading the model. The model is equal to auto model for casual LM from pre-trained, and basically my model ID, what is the model that I want to load, and any configuration if I have to keep model comma torch dot d type, right, is equal to torch dot float 16, right? If let's say right, you have the GPU, right, then you can use based on that if it is float 16 or something, or else you'll have to use float 62. Now torch dot d type, let me first see expected parameter name, torch underscore d type, and device is equal to device underscore map is equal to auto, right? Hopefully model underscore name. Let me try to load the model. Okay, I guess the model is loaded. Great. Now, what we just have to do is we just have to run our model. So this is very simple way of hosting our model. Basically, again, I'm doing it from my local system. So I can just have my prompt, and then I can even use a prompt builder for doing that. So I can just use prompt as anything, uh, what could be the cause of World War III, let's see. And then I'll have to give it, we'll have to go for the inference. So before that, I'll have to convert my prompt into basically tokenizer, right? So inputs is equal to, I'll go for tokenizer, and I can just go for prompt, comma, return underscore, I guess, tensor. Tensor is equal to pt dot to model dot device. Retrain tens return underscore tensor. Oops. Return underscore tensors. Okay, done. So we have converted, and now time to just with torch dot no underscore grad and output is equal to model dot generate inputs, comma, max underscore new underscore tokens something 200, right? And temperature is equal to 0.1, right? Add underscore token, I guess it won't be required. Let's see. Following not used by temperature. 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 Okay, done. And yes, I got the output. Output was pretty quick, and then result I can get in tokenizer dot decode, right? Outputs of 0, comma, skip underscore special tokens. You can just use this for better output. Output of 0 and print SULT, and we just go for print result. Okay, what are the consequences? And it is hallucinating actually. The model is pretty small, I guess. Wait a minute. Pad underscore token underscore ID is equal to tokenizer dot EOS underscore token ID. Hmm. Okay. Maybe I should explain new advancement in quantum mechanics. Hmm. Mechanics. Use this prompt, and since this model is very small, obviously, I do some. I don't think so. It is giving me the answer due to some reason. Maybe I'm doing something wrong. It is giving me the prompt only. Hmm. So explain new advancement, including the discovery, holographic, and development of quantum computing. This is basically it is rephrasing the question. What is quantum mechanics? Yeah, but even this is even an old model. This is not a new model. Also, it may be causing the problem. No, I do not know what is the problem. Model is loaded. It is loaded, right? Everything is fine, I guess. It is using GPU, right? Anyways, the idea was basically to get the results and everything. And if I go ahead and check my GPU also, so NVIDIA SMI, so it is basically occupying out around 3 GB of my GPU. 3 GB of my GPU is already assigned, so I can go ahead and just delete this model, right? And I can call the garbage collector to run. So basically, in order to delete model, delete tokenizer, and import GC, import GC, GC dot collect. Okay, and now so basically I have freed my memory. Gradually it will start releasing 26%, and again it is 30%. Yeah, it has started to release the memory. So basically this is how you actually remove the models from the memory. So it will gradually it will release the model from the memory. So basically this was very simple example. Now we can wrap this whole thing into maybe your Streamlit or any of the APIs you want to expose, but that you will have to build those APIs yourself. However, a more better approach is that what we can do is we should be using an ready to use APIs. Basically, there is a lot of things involved in building those APIs, and basically we will be having same APIs. We will have to give the prompt, we'll have to receive the data and everything. So I mean APIs remains the same, right? So basically what we can do is we can simply use the VLLM server, and obviously this way of hosting will take more memory. It will be even not that fast also. So basically then what we do is we switch to VLLM. It's not releasing it. Okay. Anyways, let's see. Okay, so then we will just switch on to our Colab only for few of these experiments. We'll switch on again to Colab because the reason being even running all of these things, although is easy, but yes, it takes a lot of toll on the local disk and everything, and even the speed that is provided on Colab is quite far superior. So basically, we will expose an API from Colab itself. It is doable. So let me switch to Colab. Mm, okay. So, okay, first and foremost thing, let's try to understand that why VLLM, right? We'll just try to have a look at why VLLM. Let me just run. open one more slide for you. In that case, why VLLM? Right. So the VLLM is actually addressing a challenge, and what is that challenge? The speed, right? So let it be you are exposing something on your cell phone or anything. Basically, when you expose something to the to the customer, and definitely you have to be on that level, uh, in the sense from the revenue perspective. That is, you should be exposing your model to the customers, your custom model. If you are short of the things, definitely you can go ahead with some of the existing models, go ahead with OpenAI, or go ahead with Mistral, Llama, any of these hosted models. You can go with these are there are a lot of aggregators available nowadays, right? Let's say together.ai is one more aggregator. You can just go ahead. I guess they have renamed it. Oops, this is something else. Together AI models. Right. So together.ai. So you can just, this is an aggregator where you can get all of these models, and you can just have the pricing also, that what is the input and output pricing. Right. You have Llama, DeepSeek, OpenAI. You can have DeepSeek. You can have OpenAI free models. Right. Quen, Mistral, GLM. So instead of you hosting it, you will be using these open source models. But just to make sure, first go ahead and read that at least these open models are, even this platform is not saving your data or something like that, right? You have to be sure, because if you give to your customer, you have to sign an agreement and everything, right? Now, basically, what is the thing that it is trying to solve? Now, if we have decided that, okay, we want to host our own models, then basically this is the best stack as of now. That large language models are very, they're powerful, but they're expensive to run. That is, when you send long prompts, right? It should process all of that in the memory and do all sort of things. Now, what it does is basically, as of now, I'll just try to explain you first on the whiteboard that how it actually increases the speed. This is also one very favorite questions if you try to discuss anything about AI and everything, or if you're trying to appear for any interview. Okay, so basically, we see that, you know, right. What is the case here? So basically, what happens that large language models, they take a lot of memory, right? We have already seen that, what we can do is we can take these LLM models, we can take these LLM models, we can provide direct inference, which is very costly. Our GPUs have been blasting sometimes, and even on pre-collab version, right? So then the other option is you can definitely have, uh, you can convert them into 16-bit, or you can convert them into 8-bit, right? You can convert them in any of these formats, and then you can provide the simple inference maybe from transformers or C llama or something like that, right? Then even if you are providing, sometimes, the speed is not that optimal. Now, basically, what happens when the user starts hitting very frequent hits, and too long prompts, too long prompts, then basically your system start slowing down. System is slow. Now, basically, if that being the case, then obviously we'll have to use the LLM, VLLM. So VLLM, how does it solve your problem? So it reads the prompt. So what it is basically doing the pagination part, right? So VLLM basically, it will read your prompt. It is reading your prompt, and then what it does is it creates a key value kind of thing. Key value is again a part of transformer only, but again for prompt also it is creating a key value, and then it is storing that into a cache. It will store all of this into a KV cache. It will store into a KV cache, right? Now, during generation, instead of recalculating everything, the model will just take up these nodes, and uh, it will basically have, instead of doing, so the whole idea is that GPU remains sometimes free. GPU remains free sometimes. Now, instead of it just pushing everything at once into GPU, it will basically break your attention mechanism into small uh, units. These are called as paged attention. These are called as paged attention. So this is an internal working that is okay, but definitely if you are technical or somewhat technical, and if you would like to go for any product manager or anything role, then you may be, I mean, these may be the questions you might be asked, right? So basically, this KV cache, uh, this page attention is introduced, which breaks the KV cache into fixed size pages. Basically, it will break down this KV cache into these fixed size pages, right? Now, unused pages can be swapped and reused efficiently. Now, basically, so it is trying to optimize this, that whatever the parts are being used again and again, they will be put into a cache memory. They will be put into a cache memory so that it doesn't have to load it again and again. It doesn't have to do this conversion again and again. It doesn't have to do this conversion again and again. So basically, it will load it into cache, and then it is easier to communicate through GPU. So like one statement I was telling yesterday, that nowadays the biggest rules that you see, that that he was paid this many millions, he was paid this many millions. It is not on the AI that we have been learning. So these are low level operation things wherein you have to optimize that how GPU is actually handling that data, how efficiently GPU is handling that data, because GPU is very costly. Now, let's say if there is some training that is costing $50 million, and if using some algorithm you can maybe do it in $30 million. So if you are saving $20 million, then obviously you deserve $1 million, right? So this is how the calculation goes, and this is actually dead costly, right? This whole thing, caching and moving out of the memory and all of those things, right? So basically, uh, what happens in most of the servers, request will wait until the whole request is ready. Until that time, so GPUs, what happens in GPUs, right? So in these GPUs, either they will be idle or they will be busy at once, right? That is, the whole batch of input is coming, because there is a lot of processing that is going on, right? Your prompt gets converted into tokenizer and all of those things, and then it is getting decoded, and all of those things are happening. So basically, instead of that, what it VLLM does is it does a continuous batching job. So instead of just putting it at once, it will divide it into small parts, and it will just batch it around so that the generation is uh, faster. Now, basically, the GPU is still decoding one step at a time, right? So if there is any other process, what happens that GPU, if there is any other process that need to be processed by GPU, so they keep on the most optimized way, they keep on sharing those tasks, right? They share the GPU step by step, and basically what happens, so GPU hardware is there, so many of the tasks don't have to wait immediately. Basically, it's somewhat similar to round robin. All of you might have uh, studied this round robin thing. Not exactly round robin, but somewhat similar to this round robin. Round robin is an algorithm that actually keeps your CPU busy. It is keeping your CPU busy. And here, this is an algorithm that is keeping your GPU busy, right? So this is what it is. And I just have a small visualization also how this is happening. So we can just have a look at it. We just reshare it. Now, I could have skipped this part, but it is important to know that why it is behaving faster. and how VLLM works. Right. And then here I have to open it. Mm, can you see it now? Or I have just, okay, all right. So here it is. So basically, if you see, and what is happening, so first and foremost thing, this is prompt. Prompt is to converted to tokens. Tokens is to GPU. And this is your paged attention. Now, based on speed, how much speed you want, how much batching you want to be, what is your prompt size? Do you want to use paged attention or not? Paged attention is not like optional thing. Sorry for that, right? And generate 32,000 tokens or more amount of tokens. And if you see, just if we have this prompt tokens are getting filled, and then this paged cache is getting filled, and continuous batching scheduler, single time, what it is doing, it is continuously basically giving the task to your GPU, and this is how these are three important parts of this KV cache. Now, if you see, if I just increase this tokens, or maybe I want to increase the batch size. So yes, I mean, some of the parts might increase. Now, if I increase the prompt, right, to 96 tokens, then obviously based on smaller the prompt and hence better the speed, right? If you see, if I increase this prompt, then what happens? See, even this, converting this prompt to tokens, it is going to take some time. And then all of this is done, it will be converted into KV cache, right? Tokens KV cache, right? And then basically here it is continuous batching is happening, right? So this is an easy to remember thing, basically how we can go ahead. And now let's jump to our demonstration where we should be demonstrating it. So let me go to, first I'll just show you an easier method. So basically just using some, this is exercise number 23. This is 23, and VLLM, especially it is dedicated to VLLMs only. And this will specifically run on GPUs only. It is not going to run on CPUs. This is a specific GPU version notebook. So because obviously there is VLLMs don't work on CPUs, right? So let me first go ahead and install whatever is required. I'll go for git install. I can give VLLM radio. Now, OpenAI has released a version, right? A library basically that you can use to access VLLM directly. So OpenAI has played it smart. If you have OpenAI library, you can access OpenAI models directly, or you can access VLLM directly if you have custom models. So it is easier to switch from any of these models directly, right? So we'll install it. I will have to change the runtime, right? OpenAI version. Let's install OpenAI greater than 0.1, 1.4.1. What is the recent version? 0.4.0. I guess OpenAI is already quick to install. Great. OpenAI 1.0. Oops. This has to be of the latest version, or else things will not work. The previous OpenAI version is not very much compatible. Now will just go and install from vllm import LLM and comma sampling params. Oops. VLLM is not installed. Let me install VLLM. And we will use Quen model, Quen 3 2.5. Okay, then Quen 2, Quen 3. Quen 3 1.7 is fine. Okay. If you see, if you go ahead and read, so it is talking about number of attention heads, 16 for Q and 8 for KV and all of those things. Well, it is taking some time to install. These are some standard things that I got from their website itself. It's not that I remember all of this thing by heart, right? You can visit VLLM website. There are a number of examples given. Top underscore 3 is equal to 0.5 and comma max underscore tokens. There is some problem with the installation, I guess. 256. All require pip resolver, all conflicts. Okay, done. Now let's load it. And that's it. We are done, right? As simple as that. This is a very simple way of loading it. But in this method, you will have to actually build all of the things. That is, you will have to create your own, you know, uh, like you'll have to create your own APIs and authentication, authorization. You'll have to do it yourself. But this is again one of the very easiest method. Now, second way we will see, but first let's complete it. Let's run this model and see some prompts. For wrapping and showing it, I will use a Gradio UI for doing that. I will quickly build using a Gradio UI once the model loads. So Gradio is something. Gradio is very specifically for building UI on Google Colab. Right? You can visit the Gradio website, and it like Streamlit. It also has a lot of options. But again, Streamlit is much more for building things not on Colab. It can build things for you for real time. Now this is basically for building all of the prototypes on Colab itself. You can have all sort of options. You can have, if you want to build a widget for yourself in Colab itself, right? Chatbot and everything, easy chatbot like this. So it is very easy to create. This is an image generation that I just did right now, right? So yeah, let's go back to it and let it load the model. We'll start building. Go create Gradio UI chatbot with VLLM being used for the model loaded. Generate text. Let me check first. Is it right or not? Output generated text is fine. Output return generated interface gr.interface chatbot height title quen description theme soft examples iface.launch but llm.generate correct sampling params I'll have sampling. This should do the job. Let's see. Done. My model is loaded. Oh, what unexpected retry button. Retry button. Chat interface. Chat interface, text box. The buttons are removed. Okay, you can go to this link. I can share this link with you also. You can also access this till the time my notebook is running. If you see, all other times we have been loading the model into our local, and it was not at least this fast. This time, uh, this is actually pretty much fast. You know that what is capital of France, and we can say that what is track. So this is pretty much something like, the button is gone. Wait, hold on. Demo, we go to interface, generate text. Okay, generate text, chatbot, height is fine, title is fine, description, examples. I don't need examples. It should have a text box is fine. Okay, and text box, line to placeholder, enter from. Now, what about the button? Demo.launch, theme soft, description. It doesn't have a button here. Let me try it again. I need a button basically. Now, but it is not allowing me for a button. Chat interface is fine. Wait, I don't have button. Submit. Neither is enter working properly. Ideally, enter should work. In chat interface, it creates a simple chat interface. Again, sampling params, sampling submit button. If you see, my RAM has shooted up. Usually, this small model, again, there's no submit button. I don't need examples. There was an option, description text box is equal to placeholder. Title description use on. Okay, there was a wrong parameter. And you see this time the speed is pretty fast. Although, about you, if you have any questions, uh, I want to brainstorm how can World War III start. And I guess this is a censored model, so it has returned because there is something about war and everything, right? Tell me recipe of a vegan cake. Hmm, there is something wrong. Recipe of vegan. Actually, it is not able to append this logic properly, I guess. I'll have to go ahead and check. Recipe of vegan cake. Hmm. The reason is not with LLM.generate actually. If I just go and run this, yeah, here is the answer. So basically, it is not working properly. This widget is not working properly. So I'll fix it basically, and I'll give it to you. We don't need to waste our time, right? And you see the time is actually very efficient. You can just use this percent time to record your time. Like, how can World War III start? Okay, it has taken 4 seconds. Now, even on GPU, earlier when we are doing with RAG and everything, you can try these examples. It is a better, but yes, I mean, it will bust your GPU also. It is already occupying what, 12 GB of GPU. You'll have, I mean, all embedding models and all once you go ahead and load, so your GPU will be out of memory. It says sorry, but I can't assist with that. Is a hypothetical scenario, and it is not talking rubbish. I mean, obviously, and the speed is also more. Right. This is one way. Again, you'll have to wrap it in the API, and you'll have to then expose it. The best method is definitely. I'll just restart it or restart the session. Is basically using the VLLM servers. Using VLLM servers. Right. So basically, in order to use these servers, okay, zero. And the same thing you can wrap in your Docker file. Now we can just go with pip install. We have already installed OpenAI, and we'll have to pip install by ngrok. So new things. Now these things completely come under DevOps, or basically deployment team usually manages all of these things. But yes, I mean, it is not just this. There are a lot of things that deployment team has to do, nginx, and they'll have to do all sort of things. But yes, I mean, since we know that, we should know what are the best practices to expose them. Right. Now, basically, it is as simple as that. You just have to run it. We can just go ahead, and run our server directly here. Now, obviously, this has to run on a separate thread, basically, right? I'll just I'll just show it to you once. Python -m vllm dot, I'll copy paste it rather. Okay. Dot entry points dot openai dot API underscore server, and then we provide model. Model is this. Sorry, this is my model. I'll just provide the model that I want to run. Right. Okay. And all of the options. Then what data type do I want to use? D type is equal to, it says auto, and then host 0.0.0.0, port 8000, and an API key that will be provided automatically. Authentication and authorization will be taken care of. Token ABC 123. Anything. I'll just take token ABC 123. And Python VLM API key token. And if you just go ahead and run it, this will run. And what has just happened, basically, your complete VLLM server is now ready, right? But again, like as of now on Colab, I will have to run it through different means so that it runs in the background, because I cannot. Colab is having one thread only, but in your local system, you can run it on one terminal, and then you can test it from the other terminal, right? Uh, Host ABC unrecognized arguments, quen3 1.7b, model name. Why it is showing this error? Yeah. So what I was telling you, that on basically when you are using it through your in the local or on the server, so basically on one terminal you can run it, and then basically from it will expose the keys and everything. If you see VLL server, and your server is up and running, you just have to put this in your Docker file, and then your server, production grade server, is up and running. Like I said, on Colab, I will have to run it in the background, but I have just put this command here so that you can use it anytime in the future. Right, I'll let it run first. Okay, it is doing all sort of things. I'll stop it here so that, because I will run it through the background process. So there's a no hop process using which I can run the server in background. Okay, and I can just use model. What is the model name? Port number, you can change the port number if you want. and API underscore key, something, whatever you wish to take. That's it. And we are just actually issuing the same command, but with a different thing. These are just tricks of Linux basically, so that you can just run it in the background. And then I guess no hop. Let me see if this is correct or not. Python -m, entry point, model name, D type, host, API key, and all the server logs that I want to put them in server.log. I had to search all of this online, so I do not remember all of this thing by heart, right? And I'm basically writing the same settings here. .pid. All right, and I guess this is done. It should do my job. We could vllm PID. Let's see. Cannot resolve server name, no hop redirecting. Port, oh my goodness. Uh, if you see server log is created, but I do not know on what port. Let me try to restart it. It is already okay. It has not yet occupied the memory. I guess I'll have to restart it. Okay. But will so I am basically redirecting everything to this. Okay, it has started loading my model into the memory. Okay, let it load. Okay, application startup complete. Cool. Right. Next, I'll have to bind it through some basically some IP address. You know, this is running on Colab or something. So I can use ngrok. So ngrok, you can just go to ngrok. Ngrok, right? So basically, you can just get your keys from ngrok. I have already obtained my keys from ngrok. So what it does is it will give me a public URL in these cases. So it becomes easy for me to look for all of the APIs and everything. So let me first just do that and then I can show you from py ngrok, import ngrok and ngrok config ngrok config add auth token. I have my authentication token. It's free of cost. You can get your own authentication token. That's it. And here we get. Okay. So no, it did not work. Sorry, it is config. Okay. And now let me just expose it. So from find ngrok import public underscore URL is equal to ngrok dot connect some 8000, and I can have my port number or something. I can just HTTP. This is what I need to export it, and this is my public URL, public underscore URL. Got it. Is it accessible? Let's see. Copy link address. Let's go to this place. What it says, oh my God, I have my API running. Let me visit the site. Okay, details not found, slash docs. Actually, what it is giving me, no, sorry, it was, okay, sorry, link address, right? See, you have everything. You do not need to prepare anything. Everything is present. Completion, tokenization, embedding, pooling, classify, score, re-rank, everything is ready-made. What are the parameters required and everything. You can just go ahead and use it. Cool. Let's go ahead and use it. Now time to use it, right? So I'll have to run all the authorization and authentication. API key I have. Okay, this is my API key, and where did I use the API key and all of those things? I will be needing them. API key and my public URL. This is my public URL. Public underscore URL. Okay, and now I will have to, first and foremost thing, we'll have to hit and V1 chat completions. This is something, chat completions. This is the one that we'll have to try it out. I can use this. All right, but let me use it from my program only. So API underscore key, create request for public URL slash v1 slash chat slash completion. Accept it. Let me see if it is correct or not. Headers bearer API key, correct. Your helpful assistant. What is capital of Germany? Okay. Let's see. Error. What is the response? Let me check. Mm-hmm. Why is it so? It's already exposing it to public. This is already running. Headers. Payload is model, messages, role, okay, temperature and max tokens. Request.post. Headers. Headers is authorization, bearer API key, correct. Content type, application slash JSON, correct. And data headers, okay. JSON is equal to payload. Payload, where is my payload? Payload is model, messages, temperature, done. It is already in JSON format, it is in dictionary format, but no. This is something to do with ngrok, I guess. Let me check. And let me check with one URL command. Token ABC 123. No, it is not running successfully. We'll have to reinstall everything. Mm, 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 mm. And we'll also see how basically we can do the streaming thing. Now, streaming is basically like you see in the chat GPT thing. So basically, the output is not seen at once. That is, it is seen at, it is like it is writing tokens, it is writing characters one by one. So this gives user an expression that, okay, I am getting the output, and user is not very impatient. Now, even if it is taking 1 minute to generate the output, the user is generally okay with this kind of behavior because he's seeing something. It's not like that he's not seeing anything, rather than user waiting for 1 minute and then he's seeing something. Mm, 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 Okay, let me restart it. All right. Okay. And then, okay, it has started to load. Mm, 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 mm. Okay, loading the model. Mm, mm, mm. Running to load again. Okay, now loading it. Yep, 12.1. Okay, done. Now let's hope that it runs. Okay, then it is done. And let me run this again. Okay, model and point 3, right? Mm-hmm. Public URL that is still not found. Okay, looks like it is running. V1, fine. V1 models. Strange. URL public authorization bearer token detail not found. Wait. V1 models show available models. Try it out. Execute. Error unauthorized. Okay. Just not even giving me unauthorized. Parameter. Where do I add the parameter here? V1 slash models. V1 slash models public URL. Public URL is this. Okay, done. Public URL. Details not found. Strange. Token ABC API key. This is used. Okay. $500 again response. URL. What is the problem? Public URL is this. Mm, requests. Public URL is this. Sorry. I guess it should run now. Oops. ngrok is fastest way. The same error, I guess. It's not working. Yeah, I guess no. This one is not working. But yes, I mean, the whole idea is that I had to hook it up to a different, basically IP forwarder, and this might be the reason it is not working. ngrok is failing actually. I'll have to look for localhost. Web service is not actually running or listening on specific port. Now we did run it on specific port only. Server.log. 8000 is running on API 8000. Authorization bearer token port is not even required here since URL. Yeah, I guess I will this is not actually anything wrong on our client side also. uh, Failed to open a private leg every time it is saying this. Uh, Hit on specific port only. Although if I'm running it from here. Oops, this time it is not even showing me as my service. Right. I guess if we last time we were hitting it from here, it was showing me. We might have to restart the service and do all sort of things again. The service is down. The service is not running. Okay, my service was shut down. I guess we can try it once again. At least from the API, I can show you. Anyways, we will let it load. I mean, this was not a mistake on our part at all. Basically, some configuration here and there, and this is very common going on with server things. Now, we can. I will try it once more, and we'll see where we can go. Now, uh, once we finish it off, like I have already been saying even earlier also that. I know that since you have gone through all of this course, I do not know how many months did we spend. I guess we started in April, and it's April, May, June, July, and it's August end. So almost 4 to 5 months we have spent, the weekends we have spent studying this subject. Now, obviously, there's not a kind of subject you get it in one shot. You'll have to be like, will have to be connected, and like I said that what I want is, I do understand that it is not kind of an course that I sell it and I forget it, and I want to refresh everything. I'll be posting videos. I'm also working on that I post regular videos at least once in a week, something around, like let's say NA10 is the new thing that I have to post, and a lot of things that keep on doing, and some of them, some of the videos I will post in the private. So obviously, although I'm thinking to post everything in public, but let's say if I have some topic I want to share it with a close group only, then obviously I'll share it that way. Second way, like I said, I mean, I will see that if there is any project I can enroll in, or if I find any more people, where with whom I can like get into touch, and then yeah, if there is anything, basically, whatever we have project basically, then that I'll keep on posting. Apart from that, to AR. Let me let me then again try. Hmm. Hush, we got it. Oh God. Wait. I guess public URL API key. Oh, it ran once and it was just out. I guess it is blasting. Yeah, it is blasting the memory actually. The memory is getting out of bounds. As soon as we hit one, it gets out of memory. Yeah, it is. Although it is a small model, it is not a big model. Let me try with this one last time. Endpoints, stop endpoint, agent details, and stop it. Stop the session. Okay. Now. Again, I'll have to start it again. Right. So what I was telling in the meanwhile, we'll let it start. So what I was telling, right, we can get connected, and if there is anything you want to connect personally, obviously you can just ping me on the LinkedIn. any project you want to discuss or anything you want to discuss it for the future. I am also actually working on something new, and let's see where I can reach. I am researching on things. Basically, I wanted to work on something that, because now LLMs are everywhere. So I wanted to work on something that is something beyond LLMs, or maybe where, LLMs cannot reach. So if I'm able to crack the right research, I'll maybe in few months I'll like update in the public that. But anyhow, whatever things I'm doing, uh, I will continue. My whole idea is, see, the idea is with whatever the people who love this field like me, we keep on evolving, we keep on learning, and we get connected. Let's say if tomorrow any one of you wants to start any startup, I have complete experience of raising funds, whom to connect in India, whom to connect in US, how to do all of those things. I have all of that knowledge. I have done that part uh, myself. And so if there is anything you guys want to, and I don't want to speak all of these things in the public forum, and hence basically bringing it to a closed forum. So yeah, I mean, if there is anything you guys want to, but yeah, I mean, the whole point being, the idea should not be, no one should be able to replicate the idea at least in 3 months. Whatever you built, because if you can do it in 4 months, I mean, it should not be plain insert update delete operation. It should not be plain something summarization and something like that. Some intelligence you will have to bring to the project so that it's better for you. It becomes easier to pick up everything and all of those things. Let's see, and we will always be connected. Like I said, uh, on the same YouTube channel, I will keep on posting things. And else, and yeah, please, just a reminder that if you can just put your reviews on the link that I gave. I will repost it today also. So if you can kindly just repost, I mean, just submit your reviews, whatever the honest reviews you have, that are welcome. And let's see where it has gone to. Okay, I guess it is running now. I'll run it and 8,000. Okay, copy link address. My model name is this now, 1.5B instruct. Point 2, port name should be 8,000, right? Oops. Again, some problem occurred. Not found V1 models. Okay. Okay, these are the models that I have. I'll quickly run the program. The capital, okay, glad we had it. And this time the speed is also quite fine. Right. Uh, you got it in 832 milliseconds, which is impressive. We can just say that write an essay about word unity, right? The word faces numerous climate change, poverty, inequality, terrorism, peace signs, so and so, and XYZ, and excellent. Just one example that I want to show you is that, how to do the streaming APIs, so that, because this is the basic necessity. So how to stream the APIs basically. Let's see if I can generate it, or else I'll have to write it down. Let me see. And how to basically create script for streaming API from VLLM. Max tokens is 500. Okay. And 200. I hope so. This should do, although the code it has generated is pretty complex. And it says explain how car engine works. Wonderful. Or I will make it more interesting how aeroplane engine works. And you see the speed. Can you believe it? You're running on a free GPU machine. You just see the speed. Maybe faster than some of these AI engines, but yes, obviously they have lot billions of users are using it, and this is not the case with us. We'll have one more example, last one. Let's say, uh, mm, can you explain Fourier transformation? A boring question, but a complex one. And I do not know it is correct or not. I'll have to go ahead and check, but yes, frequency variable and 1.5 billion model just doing good things, right? So here we are, and last time actually what was happening, we were uh, getting out of memory every time, and this was the reason it was just crashing each and every time. So I guess we will wrap up in that case today. And like I said, I mean, not an end, just a start for your learnings. You'll have to continue to upgrade yourself, and the whole idea is to make you guys successful.